what we're going to do is we're going to solve these algebraically or determine if these are inverses algebraically. Now remember, algebraically, to find out if something is an inverse, we switch the x and the y, and then we solve for y. So in our first one, if we switch x and y, so part A, part I start with y equals 3x minus 6. If I want to find the equation of the inverse of this, I'll switch the x and the y. And then I'm going to solve for y. So I'd add 6 to both sides, divide by 3. So the equation of the inverse should be x plus 6 all divided by 3. Does that match with what they've given us as the second equation? No. So no, these are not inverses of each other. For the second one, we have got a parabola and only part of a parabola. Can you see that we've got a parabola that's been flipped down and then moved up 3? And we're only taking the part of that parabola when x is bigger than or equal to 0. So the domain is restricted. Can you see that's what we're looking at, that half. And currently, that passes the horizontal line test, so the inverse would be a function. So that's why the domain was restricted to begin with, because they've listed another function as our second one. So we're going to see if these match up. So the first thing we do, we've got negative x squared plus 3. We switch the x and the y. And we need to solve for y. A couple of things that you could do here. You could minus the 3, and you'd have x minus 3 equals negative y squared. And then, I'll write that out, x minus 3 equals negative y squared. Then what are you going to do with that negative? How do you move the negative over to the other side? You could either multiply both sides by a negative or divide both sides by a negative. Whichever way you do, you're going to get negative x plus 3 equals y squared. So with a negative, that would be one idea to get rid of that negative. Or, can you see another strategy is to move the y squared to this side and move the x to the other side? And it will give you the same thing. So I just wanted to point that out. Either way, you're going to get y squared equals negative x plus 3. Now, when you take the square root of both sides, you're going to get plus or minus negative x plus 3. The question is, because originally we had x is bigger than or equal to 0, which ones of these are we going to have? Are we going to have the positive ones, the positive square root of negative x plus 3, or are we going to have the negative square root of x plus 3? So we're supposed to do this algebraically, but if you have a graph off to the side, it can be very helpful. What's going to happen to each of these points? Well, 0, 3 is going to go to 3, 0. And somewhere along here, we have some other points. Well, it looks like we have 1, 2. That's going to go to 2, 1. Can you see that you have this as the inverse graph? The question from the graph, is that one the positive one or the negative one? It's going to be the positive one. So one way to solve it is to look at your graph and say that green graph has to be the positive one, negative x plus 3. Another way of looking at this is to think about domains and ranges. We had originally our domain being the x values bigger than or equal to 0. What happens to all of our x values when we do the inverse? they become y values. So if our x values become y values, our range has to be y bigger than or equal to 0. And if you think of the plus or minus here, which one's going to give you the y values bigger than or equal to 0? The positive one. So that's another way that we can see which of those two functions it has to be. And since it has to be the positive one, and they've got 3 minus x, and we've got negative x plus 3, are they the same? Yes. Even though they don't quite look the same, if you rearrange it, it is the same, so yes. Those ones are inverses. So how do we verify these answers graphically? Well, we kind of did that already in part 2. We drew the graph, and we did the inverse, and they match up. But if we were going to graph y equals negative x plus 3 or y equals 3 minus x, if I was graphing that to see if it actually matches up with the green one, if I was trying to graph 3 minus x, because that was the one that was given to me, the first thing I would do is I would say to myself, well, I'm not used to having the x after the number, so I might rewrite this as negative x plus 3. And I'm going to see that negatives with the x. That's going to be a reflection over the y-axis. And it looks like I also have a horizontal translation. But I remember my special note, what happens when I have a horizontal reflection and a horizontal translation? I have to factor it out. So what is this going to do? It's going to flip it over the y-axis, then move it 3 to the right. Does that match up with the graph that we drew up here? Yes, it does. It flips it over and moves 3 to the right. For part I, the first one that we didn't do before graphically, the first equation we had was y equals 3x minus 6. What does that look like as a graph? Y-intercept of minus 6, slope of 3. Here's our one function. It has a point 0, negative 6. It has another point at 2, comma 0. So if this does have an inverse, what would we know? We would know that the inverse would have the point 0, comma 2 and negative 6, comma 0. This is, whoa, that's a pretty line. This is the inverse. What equation did we come up with? We came up with x plus 6 over 3, but the equation that they gave us was x minus 6 over 3. How do we graph x minus 6 over 3? Well, you can rearrange this. Dividing the x by 3 is the same as a 1/3 x. And dividing the negative 6 by 3 would be a negative 2. So we would have a y-intercept at negative 2. And our slope being 1/3 means we would have a rise of 1, a run of 3. Which would be that graph. Does that match up with the blue graph? No, it doesn't. So we know from there that this equation is wrong. It had the right slope, because obviously those two look very parallel. But the y-intercept didn't match up. So the questions you can do for this one are 7, 8, and then 11 and 13. And I put a little star beside 11 and 13 because they're going to make you think a little bit. So make sure you attempt those ones.